Hi, my name is Clément Gaillard. I recorded this communication because right now I live in France, and I wanted to be sure that there will be no problems if there is like an issue with my internet connection. So that's why I recorded it. So I will share my screen. So the subject of my talk today will be about the climatic potential from an historical perspective. What is climatic potential? Is the idea of understanding the climate as a resource, for example, to cool naturally a building or to heat naturally a building. And really, the concept of climatic potential is that we can use the climate to our advantages and to work with it and to use like passive solar techniques and low technology that rely on climatic potential, for example, sunshine, wind, or more complex climatic potentials. Um, I'm interested about this subject because I made my PhD thesis in urbanism and history of technology in Paris, and my PhD was about the history of passive solar and bioclimatic architecture. Um, so my PhD was titled "To Modulate the Climate," and the idea was to study really mainly in the 20th century, the second half of the 20th century, the history of passive solar techniques in France and in the US, because there were a lot of exchange between those two countries after the peak oil of 1973. So I studied mainly two types of documents. First, the work about microclimatology and local climatology. For example, the works of Rudolf Geiger or Helmut Landsberg, for example. And I also studied the history of the development of passive solar techniques in architecture. For example, the work of John Yalott, Steve Baer, Felix Trombi, Harold A, or Douglas Belcom, that you may know. And after that, I studied the diffusion of those research throughout the books or the publication about passive solar architecture. And you may know the works of Edward Masria, of David Wright too. And really, my goal was to understand the passive solar architecture really from a technical perspective and from a historical perspective too. For example, I made a, a diagram to try to synthesize the history of passive solar heating techniques. Here is this diagram. And for example, I studied the evolution of the Trombi wall, the evolution in France, but also the evolution in the US when, for example, Douglas Balcombe studied the Trombi wall in Los Alamos. And I also studied the history of passive solar cooling techniques, like the SkyTherm system or the roof pump system what was developed by Harold A, and how, for example, this system evolved after the research, for example, of Baruch Givoni in Israel or in California too. The subject of my talk today will be about climatic potentials. It comes from an article, a paper I wrote months ago about this idea of climatic potential. It was not a peer-reviewed paper. It was really a paper that was meant to be diffused and to be read by mainly a lot of people that are not really expert in building climatology. And this idea was also to try to define this notion of climatic potential really as a concept that can be used to understand the climate from another perspective and to say, okay, we can use the climate to our advantages to, for example, cool our cities or our building. The plan of my talk today is this one. First, I will talk about the intuition of climatic potential. Then I will talk about the study of solar potentials after World War II and all the research about passive solar architecture. And then I will finish with the climatic potential nowadays, how we can understand the climatic potential with our modern system. So there is an intuitive understanding of the climatic potential when you study, for example, the history of agriculture. When you had to choose somewhere, you need to somewhere you can go grow, for example, vegetables or grapes. You have to choose the best place to do it. I come from a place in France which is called Mâcon, where we make a lot of white wine. And when you study the orientation of vineyards, you see that they are really oriented in the best slopes. For example, southeast of south slopes, because in those slopes you have the best exposition to sunshine throughout the summer. But you are not you are not in the west slopes, the western slopes, because in the west you have the late afternoon sun that can really burn your grapes, so you can destroy your culture when you don't use the right orientation. From this point of view, there was really an intuitive understanding of the climatic potential, and that's what the Japanese climatologist Masatoshi Yoshino explained in this book, Climate in a Small Area, where he said that really there is an intuitive understanding of microclimatology and climatic potential in the development of agriculture throughout the history. Some scientists developed some devices to study this climatic potential. Is the case of, for example, Horace Bénédict de Saussure, who developed in the 18th century a device called the heliothermometer. So it's simply a box, a wooden box with a glass pane on it. And he used this heliothermometer to study the sunshine in the mountains places, for example, in the French Alps. And he observed with this heliothermometer that the quality of sunshine is better in altitude, in the higher places, because he observed that there was the temperature rises faster in the higher mountains compared to, for example, the valleys, where the quality of sunshine could be worse. So Horace Bénédict de Saussure really understood through 3 centuries ago, that there was a better climatic potential for sunshine in the higher places. Throughout the 18th and the 20th century, there was a growing research field around the use of solar energy. One good example is the solar steel of Las Salinas in Chile, which was developed in the late 19th century. And this big solar steel was like 51,000 square feet in terms of occupation, and it can produce like 6,000 gallons of water per day. So it's a huge amount of water. And this example shows that there was an understanding of the best place, because Chile has an incredible sunshine quality, mainly in the deserts of Chile. And so they, in the 19th century, there was an understanding of the sunshine quality of Chile, for example, to use it to produce pure water that could be drinkable. This understanding of a climatic potential was really developed by some geographer. For example, in the US, there was the famous geographer called Edward Huntington, who wrote a book called Civilization and Climate. And in France, there was also research about this, for example, by Maximilien Sor, who wrote the book on the right. And Sor said that for use of solar energy, subtropical climates of a Mediterranean type, like Mediterranean, Chile, California, present the most favorable condition, and the optimum is found in hot desert climates, Sahara and surrounding areas, and Chile too. So in 1942, there was really an understanding that there is places that can be better to use sunshine. After World War II, there was a growing interest about solar energy. That's what that is explained in this book called A House in the Sun, wrote by the historian of architecture Daniel A. Barber. And there is, after the World War II, a lot of research that were made about the importance of climate and how we can use the climate to our benefits. There is this important paper called Climate as a Natural Resource, wrote by the famous meteorologist Helmut Landsberg. And in this paper, Landsberg studied how we can use climate mainly to cool and heat the buildings. He also said something that is really interesting, is that in the 1940s, there was not a lot of data about sunshine in the US. And so he said this, I quote, "The most important gap in our knowledge is the lack of data on the intensity of solar radiation. Observations from about 20 poorly distributed stations in the United States are insufficient to evaluate the radiation factor as an additional source of heat for modern structures using new materials such as glass bricks. This calls for an expanded network of stations measuring solar intensities." And Landsberg, with this observation, tried to develop the interest about solar energy, and he published a lot of articles about climatology, how you can use climatology in buildings, and he published also this paper called Microclimatology in architecture review. And there is in the late 1940s and the beginning of the 1950s a growing interest about how you can use solar energy. And for example, there is this map made by the climatologist Paul A. Ziebel that shows 3 different types of zone where you can use sunshine with maximum feasibility, mainly in the south of the US, and where you can really use it with some complex devices. It's called engineering feasibility, and where sunshine is not really that much usable, which is called a minimum feasibility. There was in the 1950s and the 1960s a growing interest about solar energy. For example, this book, Design with Climate, published by Victor Olger, talks a lot about the use of sunshine to heat naturally the buildings. And there is a publication of really important books, like this one, Direct Use of the Sun's Energy by Farrington Daniels, published in 1964, where you can find a lot of maps about the sunshine quality in the US and the intensity of sunshine. I put some examples on the right. So there is really development of knowledge about how you can use sunshine to a lot of purpose, to heat buildings, but also to cook food, for example, or to cool naturally some buildings with a special system of cooling systems. And in the 1970s, because of problems with petrol and oil, there is this growing research about passive solar architecture. I put some example here from France and also from Santa Fe. In the bottom left, there is the house of Douglas Balcombe in Santa Fe. And there is also a lot of publication about the importance of sunshine, how you need to study the sunlight and the sun quality to develop passive solar techniques. Here's a paper that was wrote by a French meteorologist called Christian Perrin de Bruchambault. It was published in 1976, and it's called Evaluation of a Solar Deposit. And in this paper, you find a lot of very interesting maps of France, where there is a lot of measures of solar radiation in the different parts of the country. And for example, when you see the intensity of sunshine in January on both horizontal and soft vertical facade, you can see that there is a really interesting, there is really a good potential to hit building to hit passively the buildings in the south of France, because the intensity of sunshine on the soft facade is really important. Here you can see the difference between the south of France and the north of France. There is a really a huge difference in the solar radiation intensity. So from this kind of map, you can see really clearly that you can use your soft facade as a passive solar collector, and you can see that there is really an important climatic potential to use passive solar heating techniques in the south of France compared to north. There was also in US a lot of research about the climatic potential to cool naturally the buildings. Here I put some picture of the SkyTherm system. It's the Atascadero house that were made by Harold A. in 1974. And there was a lot of research about how the sky radiations depends on the dew point temperature. And there was a lot of research that were made by Raymond Bliss Jr., which is a physicist in Arizona, and also by a very famous scientist who worked on solar energy, which is called John Yellott. And when you study the history of a SkyTherm system, you see that there is a lot of exchange between the research of Harold A., the research of John Yellott and Raymond Bliss about really how you can understand the climatic potential to cool a building by radiation, by infrared radiation through the sky. And really, there is a lot of development of techniques to really understand this climatic potential, this climatic radiation, sky radiation potential. And nowadays, there's still research about this subject. But you can see with all those work that it was really an old, very an old subject, because there was a lot of research about passive solar cooling techniques that use sky night radiation in the 60s and also in the 70s. One really interesting publication about the climatic potential is this appropriate technology working atlas for the state of Texas, that was published by the Center for Maximum Potential Building Systems. And in this publication, you found some very interesting map. Here's the map that studied the application of the Trombe wall throughout all the state of Texas. And you see this gray area shows that there is an interest, there is a climatic potential to use this Trombe wall in this part, but the climatic potential is really reduced in this part of in the southeast part of the Texas, because there is humidity in the air, so it really reduces the potential to use the Trombe wall in this part of Texas. There is also a map about the climatic potential to use the SkyTherm system, so the sky night radiation system. And you see the same thing is that in the really the most arid part of Texas, there is a good potential to use these techniques compared to really the southeast part of Texas, where the humidity is too important to use the sky night radiation systems in the summer. There was also some research about this in France. Here is a map shows that to show that the how you can use different types of glass of glass, and how you use the orientation of greenhouses in different types of climates. So, for example, this type of greenhouse with really only a vertical soft glass panel needs to be used in the southern part, because you have a lot of sunshine in the summer. You don't want this sunshine to come into your greenhouse. When you, in the contrary, in the northern part of France, you can use very different types of greenhouse with a huge surface of horizontal surface of glass, because in this part the overreaching is not a big problem compared to the south of France. So how those research about climatic potential evolved, and how we study the climatic potential nowadays. There is still a lot of research about the climatic cooling potential in Europe. Here's an image that comes from the roof cooling techniques design handbook, and there is this map that shows the percent of energy savings that you can have with a roof pond system. So it shows really the climatic potential to use roof ponds system in Europe. It was published in 2006. And there is still a lot of research by a physicist about the cooling potential with sky radiation. Here's a paper that was made by Keith Sharp. So there's still a lot of research in this field. And there is also research about really local climatic potential, mainly to try to reduce the urban heat island effect, which is really a problem in France, mainly in Paris, where there was a lot of problems with a lot of problems with the urban heat island phenomenon. And so, for example, I worked with a company which is called Solenios, and they developed a software to study the climatic potential to cool and to heat naturally the cities and the buildings. And here's a map that we made. So it's about the climatic potential to ventilate naturally the buildings, and the idea was to study two types of urban morphology. So it's really this area, this zone, and you see here the intensity of the wind. So the brighter it is, the faster the wind goes. And the idea is to study the climatic potential of ventilation inside those buildings. Is also the idea is to try to find the best morphology to enhance the ventilation inside those buildings. We also made some research, some map in the neighborhoods about really how you can identify the most uncomfortable places. Here's a map to show the UTCI uncomfort. So the red parts are really the most uncomfortable zones in this neighbor. And the idea is, with those types of simulation, you can make some analysis, and you can try to understand where you can use, for example, a cooling technique like plants, like trees, and you can really use these new types of simulation to understand better where you can use the good techniques, the good technique in the right place. The idea is really to reduce the discomfort during summer, and to reduce the heat island phenomenon, because there's a growing problem in France with heat island, and there is a lot of concern about this phenomenon right now in France. Thank you for your attention. And I hope everything was clear. Maybe I'm sorry if my English is not very good. I tried to do my best, and I hope there will be a lot of questions. So thank you again for you listening.